Good morning, ladies and gentlemen. Welcome to week 5 of your SAT math prep sessions during plug time. This week we have a relatively easy topic, sophomores, and that is interpreting linear functions. Okay, so we have here f of x equals mx plus b is a linear function. Okay, now once again, please make sure you're clearly indicating your first and last name at the top of this paper, and that you are circling your teacher's name and the class that you're in. Again, if you're in more than one class, please do not hesitate to circle more than one class. So this week we're talking about interpreting linear functions. So when I say linear functions, I'm referring to f of x equals mx plus b. M is your slope or rate of change, and b is your y-intercept or initial value. Now, one of the things they're going to do on the SAT is they're going to give you linear functions, and they're going to ask you to explain what those items mean in terms of the situation, in the context of the problem. So we're going to jump right in here. This is a relatively easy lesson, a relatively short lesson, and you should have more than enough time to finish the back of the paper when we are completed. So the first example says function f represents the percentage of Mr. Wills' cell phone battery that remains X hours after he takes it off the charger in each morning. What is the meaning of the -3 in the equation? So when we look at this, -3 is attached to the x, which means that -3 is the slope or rate of change. Now, generally speaking, when we have one of these types of problems, 2 of the 4 answers will probably be eliminatable right away based on you identifying that -3 is in fact the slope, the rate of change. So if we look at this, example A, that is not a rate. Okay, it doesn't include the word per, it doesn't include the word each, it doesn't include a word that indicates that it's going up or going down, increases, decreases, rises, sinks. Words like that, those are things that indicate a rate. A is not a rate, which means it cannot be the correct answer because -3 is the rate of change. Same thing for letter B. When it says my phone battery is at 3%, that's a value. That is not a rate. So once again, your test taking skills alone should get rid of 2 of the 4 answers, and even if you don't know what you're doing, should allow you to guess at a much better situation than if you don't have the ability to eliminate bad answers. Now, from there, the only difference between letter C and letter D is one single word. Letter C uses the word increases, and letter D uses the word drains. Okay? So when we're looking at the slope, in this case, the slope is negative, which means we should be using a word that indicates negative in our description. Increases does not mean negative. Okay, in this case, our M is negative, and that is a word that indicates positive, which means that is not the correct answer. The correct answer would be that the -3 represents that my phone battery, Mr. Wills' phone battery, drains 3% each hour after it is removed from the charger. All right, let's go on to example 2. A helicopter initially hovering at a height of 30 feet above the ground begins to gain altitude at a rate of 11 feet per second. Which of the following functions represents the helicopter's altitude above the ground y t seconds after it begins to gain altitude? Well, this is a linear function. The only difference between this and a normal linear function is that we're not using x as our independent variable. We're using the letter t to represent our independent variable. So we really only need to identify a slope and an intercept in order to know which one of these is the correct equation. So when we're looking at this, there are keywords within this thing that we're supposed to realize. When we see the word initially, that tells us that that is our b value. Because remember that the y-intercept is also known as the initial value. So the 30 should be our b value. The other key word in this particular problem is the word rate. We're told that our helicopter is gaining altitude at a rate of 11 feet per second. That would indicate that 11, in particular, positive 11, because of the word gain, is our slope. So the equation would be y equals 11t plus 30. Now if you look at your options, hopefully we would all recognize that letter B is that equation. Letter A doesn't have a t, which means it can't be the correct answer. Letter C has a negative slope, which means it cannot be the correct answer. And letter D, 30 is the intercept, not the slope. So it should not be attached to the t, the 11 should be, which means that is not the correct answer. So your answer there should be B. Y equals 11t plus 30, or 30 plus 11t. Okay, and then our third and final example for today is the equation P equals 2.7x plus 8 models the percentage P of U.S. households with a computer from 1984 to 2010. So again, this function is only modeling this year range, which means the problem begins in the year 1984. Okay, where X is the number of years, and once again we see since 1984. Which part of the equation represents the percentage of U.S. households with a computer in 1984? Well, this is when the problem begins. So that would be when X is equal to 0. In other words, it is the initial value of the problem, which is our B value. So if we're looking at the equation, okay, and we're looking for the B value in the equation, that would be the thing that is not attached to the X, which means the correct answer is that 8% of U.S. households had a computer in 1984. X represents years since 1984, which is not what they asked for. 2.7 is the rate of change. In other words, 2.7% more houses would have a computer each year after 1984. And then 2.7 times X, this is something you don't normally see, would be the total change since the year 1984. So if we looked at, what does it look like in 1994, we could plug 10 in for X, and that would be the percentage change since 1984. But anyway, the only one there that makes any sense, the initial value, is the B value is 8, which is the percentage of households with a computer when the problem began. Oh, help if I could spell, probably. In the year 1984, which is when the problem began. Okay? All right, so that's it. The back side of the paper has your examples on it. Once again, as always, please turn your paper over and complete those problems on the back. When you get done, again, make sure your name, first and last name, are on the paper, and then turn the paper into your proctor. Thank you very much for your time and attention, ladies and gentlemen. Keep working hard.